Algebra 2, we're going to teach you how to go back and forth between log and exponential form and a few other things today. So sometimes you have an equation in exponential form and it's easier to work with. And sometimes you have an equation in log form and it's easier to work with. So these two are equivalent and it's super helpful to know how to go back and forth between the two of them. So you might want to think about color coding them or drawing some arrows until you get the hang of it. So when we do this, b to the y equals x, but in the log form, your y comes around here and it becomes the answer. This b is always the base, and if you remember what we did yesterday, this is log base b of x equals y. And so then we have the base comes down here and becomes that, and then the x just goes to the other side of the equal sign. So right here, you say this as log base b of x equals y. That's how this is read. And so to change form, to go back and forth, to change form, sometimes we say drop and swap. And what drops is the b. So from exponential, the base drops down here to the base. So the b is what drops. And then the x and y swap places. So here the y is in the exponent, and then it goes to the other side of the equal sign. Here, it's what x equals. It comes to the other side of the equal sign. And then we have this one rule that we have to follow. B has to be greater than 0, and b cannot equal 1. These are the two rules that we will follow. So the first thing that we're going to do is we are going to go back and forth between log and exponential form. So when I look up, I'm going to label this first. So that says log base b, so that means the 2 is the b, of x, the 16 is the x, equals y. So this is how I label the parts. And then in exponential form, it's b to the y equals x. So this is how I'm going to plug it in. So that means I have the base of 2 raised to the exponent of 4 equals 16. So it's hard to understand if this is correct. However, when you rewrite this in exponential form, you should absolutely be able to plug this into a calculator and figure out if this is correct or not. So if you plug 2 to the 4th into the calculator, that is definitely 16. So you can know that you wrote it correctly by performing the operation. This says log base b of 4, or log base 4 of 1 equals 0. All right, so when I label, there's my b, x, and y. Here's my form that I'm going to plug it into. So the 4 drops down and becomes the base. The 0 moves to the exponent, and the 1 moves to the other side. 4 to anything to the 0 equals 1, so that is absolutely a true statement. Here, when I drop and swap, the 12 comes down and becomes the base. The 1 goes to the exponent. This goes to the other side. So 12 to the first equals 12. That's a true statement. I will say that this right here is a fun fact to know. So anytime your base and this number are the same, that always equals 1. That is a super fun fact that's going to show up on the back side of the notes. And then once again we have fractions, and so there's my b, there's my x, and there's my y. So this says 1/4 to the negative 1 equals 4. And you can put that in your calculator and find that that is a true statement. So this is how we go from log to exponential. Now we're going to take a new set of equations and we're going to go backwards. So now we have an exponential and we're going to write it in log form. And so here I have log base b of x equals y. So that's from above. And what do I need to know? I need to know the log is the exponent. And the base is the base. So this b here in the log, you read that as log base b. So that is always your base. And our x and y are just going to switch. So I have 5 is my b, 2 is my y, and 25 is my x. So when I write this, I have log base 5, 25 comes to the other side, and then 2 goes to the other side of the equal sign. That's how your x and y are switching places. I highly recommend that you label them until you get good and comfortable with it. So there's my b, there's my y, and there's my x. The 4 is always the base because that is your exponent. So therefore I have log base 4, 2 comes to the other side, 1/2 goes to the other side. So log base 4, and then the 1/2 and 2 switch sides. Right here I have log base 4 of 1/64 equals -3. And this is log base 10 of 1 equals 0. So that's how you go back and forth from log to exponential. And over the course of the next couple days, we will come to learn, like, why do I want to use the exponential form? Why do I need to change it to the log form? So we'll learn how one is more helpful than another in certain instances. On the back side, we have a couple of special ones. All right, so I'm also going to jot down that helpful formula. B to the y equals x. Log base b of x equals y. All right, so that is how you go back and forth from the other side. The first special rule is logarithm of 1. So log base b of 1 equals 0. Why is this true? This is true because if you change forms right here and you change to exponential, that says b to the 0 equals 1. So therefore anything to the 0 power is always 1. So if I had log base 4 of 1, and you had to figure out what that is 0, because anytime that you have a 1 right here, that's always going to equal 0. And it's hard to tell from this form, but if you change to exponential, that reads 4 to the 0 equals 1, and that makes sense. The next one is log base b of b equals 1. So you want to look for any time that your base and that big number are the exact same, they always equal 1. Why is that? Well, let's change form, and it's easier to show you why. So when I drop and swap, this base b comes down, the 1 goes to the exponent, and that b goes to the other side. You're like, oh yeah, b to the first is certainly b. That's why. So if you wanted to see what would it really look like, so if it said log base 5 of 5 and it told you to evaluate that, these are the same number, that equals 1. If it had log base 3 of 3, that equals 1. So anytime the base and the big number are the same thing, it's always 1. We have a common log. What is a common log? It is a log with a base of 10. And why do we need to know that? Because your calculators are set to a base 10. That is why it's super helpful to know or get some things into a base 10, because that's what your calculator knows how to do. Sometimes we drop the 10. So if you ever see anything that looks like log of x and there's no base down here, that is an implied 10. That would be the same thing as writing log base 10 of x. So no number implies a 10 right there. You are using inverse properties. All right, so these are a little tricky. All right, so that b, that's your base. That b to the x, that is all serving as 1 unit. So if you change form and you write this in exponential form, that would read as b to the x equals b to the x. So that is a true statement right there. So basically, anytime that b and that b are the same thing, your answer is always going to be the exponent. Same thing here. So I have this b, and my exponential is a log, but I have a b right there. So this is actually in exponential form, and I'm going to change this to log form. So this is exponential. You just have to know that the log is just simply part of your exponent. So when I change form, I have log base b, the x comes to the other side, the exponent goes to the other side, equals log base b of x. So anytime that you have a variable raised to a log and those two are the same, they end up basically canceling out, and that's why it just simply equals x. Simplify the following. All right, so I have 10 raised to the log of 4. All right, so this answer I can tell you is going to be 4. Basically because you're looking at this rule over here, and that is the rule that you're applying. We also said at one point in time that if you don't have a base, that it is an implied 10. So I have log base 10, and there's a 10 down here, so these kind of cancel each other out, and that's why 4 is the answer. If this is harder to see, then change it into log form. So in log form, you would have log base 10, this 4 comes over, that exponent goes to the other side. So whether I have a 10 here or I leave it blank, this is still the same thing. Let's see. This 5 and that 25, they aren't quite the same, but I know that I could write 25. I know that I could write 25 as 5 to the second power. And then I will have that 5 and that 5 that match. So this would be log base 5 of 5 squared raised to the x power. So we're going to clean this up a little bit. And this is log base 5 of 5 to the 2x. So that 5 and that 5 are the same. And so this is going to simplify down as 2x. Doing good. What is the value of each below? All right, so I have this change of base formula that comes in handy sometimes. A change of base formula is if you have log base b of a, you can rewrite this as log of a divided by log of b. So on the next 4 problems here, you can probably do it a couple of different ways. So this is the first way. The first way is to change it and write it in exponential form. So we don't have what it equals. This is the one and only one time in your life where you're allowed to add in an equals y. So now that I have log equals y, all right, so this is my b, that's my x, and that's my y. So if I change form of b to the y equals x, that means that I would have 5 to the y equals 125. So we did these kind of problems the other day. So I need you to write 125 as 5 to the 3rd power. So I can rewrite this as 5 to the 3rd. Since I have the same base, I can set my exponents equal to each other and know that y is 3. You could also use the formula. So the formula says log of a. So that 125, that's your a. So take log of 125 divided by log 5. So here's why I did that. Remember I said a minute ago that if there's no number right there, then you have an implied 10. So I can do this totally for calculator purposes. So now you go log 125. In your calculator, what is super important is you have to hit enter after that, and then go divided by log 5, enter, and your calculator will tell you that that is 3. Number 4, add in an equals y, change form. So when I drop and swap, that gets me 4 to the y equals 32. So I can't write 32 as 4 to some power, so therefore when I get my like bases, I'm going to have to use 2. So 4 is the same as 2 squared, and 32 is the same as 2 to the 5th. Here I have 2 to the y, so that's just 2 to the 2y equals 2 to the 5th. My bases are equal, so you're going to drop them and set your exponents equal. Divide both sides by 2, and you get 5/2. If you wanted to enter it in your calculator, you would go log 32 divided by log 4, and in your calculator, it would either say 5/2 or 2.5 for a good final answer. Try 5 and 6 on your own and check my notes.